This is part one of a screencast covering electrical power generation. This is intended for my various physics classes. When it comes to generating electrical power, the most common way of doing so is by burning fossil fuels, whether they be coal, petroleum, or natural gas. This right here is a photograph of the Scattergood Station. It's a coal-fired power plant located along the coast here in Los Angeles. It's down near the airport. This is the Scattergood Station. The basic energy transfer that occurs in a coal-fired power plant is straightforward. You first of all start with coal, which is a very dense form of chemical potential energy. It burns at a very high temperature. And then the heat from the burning coal is used to convert water into a high pressure steam. This then rotates a turbine, which then subsequently rotates the generator, thereby producing an alternating current. In order for this process to occur, you do need to have water nearby. So you're always going to see a coal-fired power station, for example, located near a river or near the coast. There are some major disadvantages, of course, to generating electrical power in this manner. Number one, of course, is that coal and other fossil fuels are a limited resource. Once you dig it out of the ground and use it in this manner, it's gone forever. And there's no way for us to replicate the coal manufacturing process that the Earth itself naturally undergoes. It literally takes millions of years for the Earth to convert decaying biomatter into coal, petroleum, and natural gas. There's no way for us to replicate it. And then in addition to that, of course, are all the pollutants that are left over after burning coal in this manner, which are then just released into the environment, released into the Earth's atmosphere, thereby contributing to anthropogenic climate change. That is, climate change caused by human beings. The basic physics behind climate change is rather simple and straightforward. It has to do with what is called the greenhouse effect. So you first of all start with sunlight, incoming solar radiation, which then strikes the surface of the Earth. Some of that energy is absorbed by the world's oceans. Some of it is used by plant matter and photosynthesis, but most of the energy is just simply reflected off the Earth. However, if the Earth's atmosphere contains certain types of gases called greenhouse gases, then a great deal of that energy is actually trapped within the Earth's atmosphere and doesn't make it back out into space. So it turns out that carbon dioxide, which is one of the byproducts of burning fossil fuels, is an excellent greenhouse gas. It basically traps the energy within the Earth's atmosphere, thereby warming the planet. So what are the alternatives then to burning fossil fuels to generating electrical power on a large scale? One option is to replace the burning coal with instead a nuclear reaction in what is called a nuclear fission power plant. This is the photograph of a nuclear fission power plant located here in Southern California. This is the San Onofre nuclear power plant near San Clemente. The basic idea of a nuclear power plant is rather straightforward. You take an already existing heavy nucleus, like uranium-235, for example, and you use the already naturally occurring process of radioactive decay to then use as your heat source. So as uranium-235, for example, slowly decays into lighter elements via the equation E equals mc squared, it releases energy as heat. You then use that heat to turn water to steam, to then rotate a turbine, rotate a generator, and then therefore create an alternating current. It turns out that there are some advantages to generating electrical power in this manner, definitely over fossil fuels. Number one, the energy density associated with the nuclear reaction process is much higher than the energy density associated with the chemical potential energy of coal. So this then means that you need less material in order to generate an equal amount of electrical power. In addition to that, when you use nuclear fission as your energy resource, there is no greenhouse gas byproducts that are produced in the process. But there are also some major disadvantages to generating electrical power in this manner as well. The major disadvantage is the waste that is left over after the nuclear reactions have occurred. The waste itself is highly toxic, it's very damaging to the environment, and it's also highly radioactive itself. So then therefore the question becomes, of course, is what do you do with all of this stuff? Right now, all of this stuff is basically just stored in barrels at the site of the nuclear power plants themselves, but that cannot be a long-term solution because this material is literally harmful to the environment for tens of thousands of years. So for this reason, and due to a number of accidents that occurred with nuclear power plants in the 1970s and 1980s, No nuclear power plants have been built since that time. But we still have this problem of the radioactive waste. That is, what do you do with it? One solution is to just simply bury the material. And a burial site for the United States nuclear waste has actually already been built. It's at a place called Yucca Mountain in Nevada. It's basically in the Nevada desert. It's in the middle of nowhere. It's in a geologically stable environment, and the water table in the Nevada desert is actually well below the depth of the mountain itself. The question is, however, is can we actually store the radioactive waste at this facility, basically bury it for tens of thousands of years without it leaking into the environment? The basic idea behind Yucca Mountain would be to transport the material there by train and then just leave it underground in these vessels in these deep tunnels, like so, and just literally let it sit there for tens of thousands of years. That's how much time is necessary for the material to actually become harmless. As you might guess, however, there has been a great deal of political opposition to the project by the various politicians and political parties in Nevada. Nevada is also a swing state when it comes to presidential politics. So, because of all the politics connected to this project, it actually hasn't been used as of yet, and an alternative solution is being explored. Okay, and then after burning fossil fuels, after nuclear power plants, the next most common way of generating electrical power is by means of a hydroelectric dam. So a hydroelectric dam basically uses a controlled waterfall as the energy resource. This right here is a photograph of Hoover Dam, which was built in the 1920s. Hoover Dam is along the Colorado River, and it actually supplies a great deal of the electrical energy used in Southern California. So here's the basic idea of the energy transfer that occurs within a dam. So you use the gravitational potential energy of falling water through the dam itself as a means of rotating your turbine, rotating your generator, and thereby producing an alternating current. It turns out, however, that there are some major disadvantages to hydroelectric power. It's actually very destructive to the ecology, both upstream and downstream from the dam itself. Behind the dam upstream, when you construct the dam, it leads to the creation of an artificial lake. And then, of course, there are also limited places to actually build the dam itself. You're basically confined to a place where there's a river. Okay, this concludes then part one of this screencast covering the generation of electrical power.